Welcome once again to Product One's technical web series. Today we're going to be looking at sheet metal. So sheet metal is a basic functionality inside Creo Parametric. Essentially, sheet metal enables you to create objects, components, assemblies using thin pieces of metal. Let's get started. So what I'm going to be attempting to create here is the CPU tower or a computer box. So this is how it works. So just to save time, I have created a couple of sketches. So I'm just going to start with the overall, what I would regard as the wrap. So with sheet metal, whenever you engage any object and you say you want to create a sheet metal part, you will realize that the first thing that the system enables you to do is to specify the thickness of the plate. So I'm going to just select 0.6 for this particular demonstration. So of course you can have an array of things. As you can see, all I'm having here is a constant thickness all around, which is essentially what sheet metal is. You don't have a situation where you can create variable thicknesses, because when you've got a piece of plate, it does not work like that way. So this is going to be the overall, I would call it wrap. And then what I'm going to do here is create the back panel. So with the back panel, I'm going to do pretty much the same thing. As you can see, this is a component in standard mode. And if I were to engage or take this to sheet metal, all I have to do is just say sheet metal. So because there's no geometry to select, I'll just pick the sketch and say create an extrusion. What I'm going to do here is specify the length of the back panel. And you'll be aware that the back panel is actually not covering the entire portion of the previous component. And that's by design, purely because I want to showcase the flange creation portion of it. In a sense that I can create a flange like this and have the flange all round. And this is nifty because what I intend to do, as far as the flange is actually concerned, is I want to go and modify the shape, and instead of having basically the flange to be 90 degrees, I'm going to go and say, how about I make this flange to be in this manner? So this is purely because I want to take this approach. And I can, of course, modify or add some level of control or parametric in terms of this. So this is the design. So let's say maybe I want to make this 0.6, and of course I can tweak this value as well. So now that I'm done with this is essentially what I have. So what I have here is a back panel that's folded, and as you can see, you can still open, let me just open this component so that you see the power of sheet metal. Just from this part here, not only can I envisage or view what I've just created, I can also look at, can I basically unfold it as well? Basically, this is the part that you send it for laser cutting. So let's carry on. So now that we've got the back panel, what I've done with the top panel is a little bit unique. With the top panel, all that I'm going to do is just resume it so that you get to see, because the component has been there. It's just that I've hidden it for this particular design. So this is the back panel, the top panel rather. So the top panel itself is just a solid block. And what I like about this is, without even starting from sheet metal, you can start modeling your components in a solid format. What this gives you is the power to go into sheet metal and tell the system that, look, you know what I want to do? I want to create basically a shell. So this means that now I've specified my thickness. This is the thin surface. Now I can't unfold this because there's a couple of things missing. So I can immediately say, you know what? I identify what's missing here. So how about we start with a couple of things? So let's start with edge bands. So I'm going to say this part and that portion here is actually bent. The same applies with this area and this one here. So as you can see, you're dictating where you're going to be having what we regard as bands. So this is where you're going to be folding the material. So these are the areas, and here I'm going to just have what we call a rib in all the other respective corners. So how I do that is I select a feature called edge rib, and this is what I have. So with creating ribs this way, you get to identify certain areas, as you can see there, that might be a problem. So I'm going to show you how you can counter that. So there's my rib feature. So I'm happy with this. So what I'm going to do before I forget, maybe let's just touch on this. I'm going to create an item called a surface rib. Surface rib is essentially you selecting a surface, either purely because of deformation and so forth, you get to select it. And if you can look, you can now unfold this component. So that's the power of sheet metal. You can go either way. You can start from a plain sheet of metal, or start from a solid, go and create your component. So this is what I have. And maybe just before I forget, let's just quickly create the cutout. So this is where I'm going to have my power button, LED lights, and so forth. So what I'm going to have here is I'm going to pull up what we call save sketches, and this is purely to speed up the process, to be honest with you, because I could easily draw those shapes that way, but it does help if you've got a library of sketches that you can quickly rely on, because all that you do is simply drag and drop, and just like that I've got cutouts. As you can see, this is where I'm going to have my power button, 2 USBs, the aux ports, and probably maybe one of the LED lights, just so that you can see if this component is on or not. Now, this is starting to take shape. Before we go any further, one can actually say, I need to create a little bit of ventilation here at the back. So just as I did with the top plate, this is what I'm going to do. I'm going to rely on save sketches purely because I don't want to waste any time on this, because as you can see, you're always in control of what you are generating. So with sheet metal, you get to choose whether you're adding surfaces or removing it. As you can see there, I'm removing surfaces. Maybe a couple of other things as well is I can create numerous slots, which we will take full advantage of later on. So just as you've seen, I'm just going to pull up a save sketch, just simply drag and drop. So there's nothing into it because as you can see, these are normal rectangular sketches with holes on either side. And what I'm going to do with this is just quickly select what we call a pattern. Of course, with patterns, you can choose whether it's direction or dimension. So I'm happy with the spacing. I can specify the number of members. Maybe let's make it 50. So there is the cutout. So maybe let's just finish this off with one last cutout that we need desperately. So the cutout that I'm referring to is of a power source. So you don't get to see the image. So the cutout that I have here now is of a fan, and of course the dripping plug point, or the kettle plug. So this is what I have now. So if I cut this out, this is what I'm left with. So I can go to great lengths and assemble these components and so forth. In fact, maybe let's quickly assemble one or two of these components, but so that you get the idea. So let's start with maybe let's start with the power source. So what I've done is I've created what we call component interfaces, just to speed up the assembly of this. So as you can see, this is the selected surfaces, this here, and of course this here. It automatically places the part. Last but not least, maybe let's actually pick up a switch as well. The switch is exactly the same scenario where I pick the surfaces involved, and last but not least, this is where I want to place it. So I've just generally assembled two components. Of course, you can go the orthodox way where you pick a part, you specify to say, okay, fine, this is the fan that I'm dealing with, and because of that, this will be the mounting surface, and I'm selecting the surface at the back, and of course select the mounting holes and make it correspond to the surface over here. Surface I'm talking about is the cylindrical surface in this area. So I'm gonna leave this at that. Of course, I've got a net that I could actually put in there, or part and parcel of this is maybe entities such as this. So this is one of the places that I've got. So let's say maybe I want it here, and just like you've seen before, I'm going to select the corresponding holes. And so this is essentially what I have. Of course, I can put in what you call closure strips in there, but I guess you get the idea. So I think if we were now to move back into sheet metal, so this is what I'm going to do now. So let's say for whatever reason, I require a little bit of ventilation also on the body of this. I can go about specifying what you call forms. So there's numerous forms that one can choose from the library, and you can even create your own as well. So let's actually choose a louver. So this is the louver that I've just selected here. In fact, let's maybe go the other way. So I'm going to specify the respective surfaces. In fact, let's just choose the first surface to be at the top, and then maybe the secondary surface to be here. So of course you get to choose where you want to place these. So let's say maybe I want this to be 60 on here, maybe let's make it to be 50. So all that I'm having now is cut out onto the inside. Maybe that's design preference, so this is what I prefer. And of course, as you've seen before, I can pattern these. If I were to choose direction pattern, I'm going to select this, and let's specify that this will be, let's say, let's make it 65. Total number of members, let's say 7. Yeah, that seems to be just about right. And I can also add a directional pattern as well, 2 second directions. So whereby I say I want 10 members here, and maybe going the other way, let's make it 50 or whatever the case is. Maybe let's make it 60 as well. All right, so I'm just essentially using 10 seems to be too much, so let's make it 8, give or take, maybe 70 on this. All right, so all that I'm doing here is I'm creating these cutouts to have extra airways onto my sheet metal part. So of course this is up to you. You can have different types of perforations to allow the air to come in, or whatever the case is. Maybe here the client wants to have a glass or perspex so that they get to see what's inside the PC. So you can do that as well. So let's just say that I want the cut to be, let's say 15, because I only want it on one side. So that is the power of sheet metal. And I think just to do justice to this assembly, let's just assemble some of these items over here. So these are the power button that I was referring to, and maybe just so that we complete this. So this is what I have, and let's just select that surface, and maybe let's make it coincident. So that's it. So that's us having the power of utilizing sheet metal to create products such as this. So of course you can go a little bit further than this. You can even say, how about you want to create a sheet metal whereby you've got, let's say, an existing cutout, you want to bend that particular cutout. So that's simple, purely because you can have, let's say maybe we're creating a slot for the CD-ROM on the other end. So let's say this is what I have. In fact, let's just refine the sketch a bit and make it like this way. So what I'm going to have now is removing material, utilizing a thin plate or thin cutout. And what I like about this is I can actually say I understand that I've got this cut here, so I can say I want to generate a band, and by just doing that, there is my sheet metal band on this product. So this is the power of sheet metal, whereby you're utilizing constant thickness plates to generate complicated products such as your toaster or whatever you can desire. So if you like this video, please subscribe. Do not forget to hit the like button as well, and the notification bell for more videos as this. Until next time, goodbye.